Welcome one and all. In today's class, we will be studying the relationship between the sides and the angles of a right triangle. You all are aware that in a right triangle, you have one angle which is of 90 degrees and the other two angles are acute angles less than 90 degrees. We are going to study about the relationships between the three sides of a right triangle and the acute angles of a right triangle. That is what is the motive of today, because at the end of the day we are dealing with the measurement of triangles, and this is what is the starting of it. So today's venture is to teach you what is the meaning of trigonometric ratios, also called trigonometric functions. What we are going to do is, we are going to pick up a right triangle and define certain ratios in accordance with the sides of this right triangle, and those ratios will be called trigonometric ratios. Let's write the definition and get ahead with it. The ratios involving sides of a right triangle are called trigonometric ratios. Why are they called trigonometric functions? That will be clear to you after a certain while. Right now we just need to focus on the word ratio to understand what do we do to actually come up with the ratio of sides of a right triangle. In order to understand trigonometric ratios, we need right triangle in picture. And I told you what is the meaning of triangle of reference. If you all remember, what was triangle of reference? Here is the coordinate plane before you, made up with two lines which meet at right angles with each other. This is your x-axis, which is the horizontal line x dash OX, and this vertical line YOY dash is your y-axis. What I asked you was, take this OX to be your given initial ray and O to be, that is the origin, to be the end point about which the rotation will take place. What you do is, start rotating and reach to a terminal side, say this particular ray. In that case, the angle which is formed is known as the angle of, this angle is known as the angle in standard form. And suppose you take any point P on the terminal side of this angle and you drop a perpendicular PM on the x-axis, this particular procedure results in a triangle, in fact a right triangle, which is MOP, known as the triangle of reference of the angle XOP. This is what is a right triangle before you, also known as the triangle of reference. We are going to deal with such right triangle and then establish ratios with the help of the sides of this right triangle, and then come up with what is known as the trigonometric ratios. Now what did I do over here was, I started rotating my positive direction of x-axis, which I took as the initial side, and I ended up at the terminal ray lying in the first quadrant, and that resulted me in an angle theta. I can do one more thing, which is, in order to get this triangle of reference, I can also start rotating this particular side and then reach up till here. That is, the terminal ray is lying in the second quadrant. In that case, if I take a point on the terminal side, drop a perpendicular on the x-axis PM, then again this is going to result in OMP, which is a triangle of reference. The only difference is the terminal side of this particular angle, angle XOP, and the terminal side of this angle X dash OP. These two angles have their terminal sides lying in two different quadrants. The third way in which I can get my triangle of reference is that if the terminal side lies in the third quadrant. Take a point P on the terminal side. We need to follow the exact same procedure to get the triangle of reference. Take this point on the terminal side and drop a perpendicular on the x-axis. This again results in a triangle OMP, which is the triangle of reference. Another way in which I can do that is, the very last way is when the terminal ray lies in the fourth quadrant. In that case, again do the same thing, which is take a point P on the terminal side, drop a perpendicular on the x-axis. What you obtain is another triangle of reference, that is triangle OMP in this case. In every case, the triangle of reference that is coming out is a right-angled triangle or a right triangle. What am I interested in is, I am interested in forming ratios of the sides of the right triangle. Over here, if you carefully observe, I am going to take one angle as my important base, which is this angle I am going to take as my focus angle. What I have done is, out of the two acute angles present in a right triangle, I have just fixed one angle in every case, which is one of the acute angles out of the two acute angles present in a right triangle. The next thing is to understand what is it about the sides that we need to know. Carefully observe firstly in this case. If you observe the side PM of the triangle POM, the side PM, if you carefully observe, is a side lying opposite to the angle theta. And that's why I name that side which is lying opposite to my angle theta as the opposite side. Mind it, the first step was to fix an angle theta. And then corresponding to that angle theta, PM is standing here as the opposite side. If you move to the other triangle of reference also, the side opposite to the angle theta is your PM, and therefore that stands for the opposite side. Over here again PM is your opposite side, and over here again the side opposite to the angle theta is your opposite side in this entire triangle of reference. Moreover, another side is there which has a name. The side which is adjacent to this angle theta, which is out of the three sides of this triangle, OM, PM and OP, PM happens to be the opposite side of the angle theta in every case. What about the side OM? The side OM is adjacent to the angle theta, and that is why it has its name to be the adjacent side. Similarly, over here also OM happens to be the adjacent side. Over here again OM happens to be the adjacent side of the angle theta, and over here again the same happens. Next is the third side. That means with respect to the angle theta, we have made one side to be the opposite side of angle theta, adjacent side of the angle theta, and the third one is the largest side of this triangle. You all know what it is called. It is called the hypotenuse. This is what is the name of this largest side of this right triangle, which is the hypotenuse. This is what we already have understood, and thus in this right triangle, the three sides which make up this right triangle have got their names. One is the adjacent side, one is the opposite side, and one is the hypotenuse. And all these are with respect to a certain fixed acute angle theta inside the triangle of reference OMP. Now understand one more thing, which is this point P lying on the terminal ray which is used to make this triangle of reference. Obviously, this point P has certain coordinates. What happened to be them? Well, over here, if you take the length of OM to be equal to, say, x units, this length, and the length of PM to be equal to some y units. Suppose this is what you take. In that case, this is your x units, these many are your y units, and therefore P becomes the coordinate x, y. Similarly, over here, if you take OM to be x units and your PM to be y units, again this point becomes this coordinate pair. Follow the same thing in these two cases also, and you have P being the ordered pair x, y. What is special about the difference between x, y in all the four cases is that in the first case, your x and your y both are positive. In this case, your x is positive and your y is also positive. In this case, first I should go here, because your entire triangle of reference is in the second quadrant. What happens is that your x becomes negative, but your y remains to be positive. So your x becomes negative and your y becomes positive in this case. If you come up here, your x becomes negative, your y also becomes negative, and here you have x is negative and y is also negative, right? Whereas over here, your y becomes negative and your x is positive. So x is positive and y is negative. This is what is the difference in x and y in all the four cases. If your triangle of reference is lying in the first quadrant, then both the components of the ordered pair x, y, which stand for point P, will be positive. If your triangle of reference is lying in the second quadrant, in that case, both the components of the ordered pair x, y, which stands for representing P, will have what kind of a behavior? The first component will be negative because it is lying on the left hand side of the x-axis, and the second component lying on the above side of the y-axis will be positive. That is what is going to happen in the third and fourth also. What I am trying to say is that if the triangle of reference lies in the third quadrant, in this case, the first and the second component of the ordered pair representing the point P will have this kind of a behavior. Both will be negative, and If the triangle of reference lies in the fourth quadrant, in that case, both the components of the ordered pair x, y, which represents the point P of this very triangle of reference, will have such a behavior. Once we have understood all of this, it's time to start understanding trigonometric ratios. But one thing should be very, very clear in your mind. I was able to name the sides of this triangle of reference as the opposite side or the adjacent side just in respect of this angle theta that I chose in the very first case. It is with respect to this chosen angle that I have my adjacent side and I have my opposite side. So let's get started by forming ratios of the sides of this right triangle, which stands here as the triangle of reference. The very first ratio that is going to come in the picture is the ratio of opposite to the hypotenuse. This is what is the first ratio. That means over here you need to take the ratio of the opposite side of the triangle of reference with the hypotenuse of the triangle of reference. In every case, the opposite side is represented by the side PM and the hypotenuse is represented by the side OP. So in the very first case, I am taking the ratio of the side PM with the side OP of the triangle of reference OMP. The second ratio that I am interested in takes the ratio of adjacent with the hypotenuse. What is the adjacent side in each of the triangle of reference? The adjacent side is OM. And the hypotenuse remains the same, which is OP. The third ratio that I am interested in takes the ratio of opposite with the adjacent. What is the opposite side? Opposite side is PM and the adjacent side is OM. These three ratios in the first case I have defined of the opposite side with the hypotenuse, the adjacent side with the hypotenuse and the opposite side with the adjacent. This is what I have defined. Now, as I told you that I named sides to be opposite or adjacent with respect to a certain fixed angle theta inside the triangle of reference. And that is why if I further express them, what are they going to turn out? If I talk about PM upon OP, what does it turn out to be? If I talk about OM upon OP and PM upon OM, what do they turn out to be? Let me tell you one more thing about these triangles of reference. Over here, you always have to understand that the hypotenuse, which is representing the length or basically the distance between the point O and the point P. This distance between the point O and the point P is what turns out to be the length of the hypotenuse OP. And this I am saying suppose is equal to R units. And R is always going to be greater than 0. What I am trying to say is the length of the hypotenuse is never ever negative, because that is nothing but the distance between the point O and the point P, and distance can never be negative. But if you talk about X and Y, which are the lengths of the opposite and the adjacent sides, they can be positive or negative depending upon in which quadrant is the triangle of reference lying. But the hypotenuse can never ever be negative. It is the length of the adjacent side and the opposite side which can be negative depending upon they are the adjacent and the opposite side of the triangle of reference lying in whichever quadrant. And therefore, if I